My name is Chris Rudd and I'm one of the Pro-Vice Chancellors. And it's my great pleasure to introduce Steve Rayner, who's going to give the first talk. I just should point out a kind of note to the organisers that when we have events in Highfield House, there are usually cupcakes, which is great for getting members of senior management along. So just might want to think about that for the programming next time. But seriously, many congratulations on putting together such a rich programme and so many wonderful speakers, one of whom we will see and hear from in a moment. I just wanted to add a couple of thoughts to the overall agenda. My responsibility here is knowledge exchange and external engagement. And I think one of the great joys of working at Nottingham is that it is such a large, comprehensive, diverse organisation. And there is such a strong tradition of interdisciplinary research, most of which is driven at grassroots level, and it's not driven by social engineering and financial inducements from research committee. And for me, I think that's one of the great institutional strengths, because it keeps us engaged, it keeps us challenged. It's great for student experience, it's great for radical innovation, and it's actually pretty good for getting grants as well. But fundamentally, it's really important for society and for the university's stakeholders. And there are examples of that all over our campuses. You've only got to go up to the northern fringe, where you can see the eco-houses, where we're studying the interaction of technology and individual occupants. When we look at the biofuels programme at Sutton Bonington and the ethics around the use of food and non-food crops, and even right back to the early days with Don Grierson's very first genetically modified tomatoes. So there are lots of lessons, and the science, technology and society agenda has always been particularly strong at this university. And it's about putting science into context and putting context into science. And somebody who brings a great deal of context in that respect is Steve Rayner. He's director of the University of Oxford's Institute for Science, Innovation and Society, and has sat on very many policy bodies around the world in Europe, US and the UK. He's an honorary associate of the Lieberhume Making Science Public programme. He's consulted for very many multinational organisations. He's delivered research programmes for most of the federal agencies in the USA, and he's got a very distinguished academic record. So really there could be nobody better to discuss how the different disciplines interact and can help us to unravel some of the complex issues around climate change, around evidence, uncertainty, and societal values. So please welcome Steve Rayner.
Thank you very much for the very generous introduction, and thank you very much for the invitation to come here today. And I apologise for parachuting in on the last day. It's not something I admire much when others do it, and I did it very reluctantly, but Rana was very persuasive that I should come, despite the fact that I was constrained in my space available. But I do hear you've been having some excellent conversations over the past 2 days, and hope to hear more about some of the things that you've been talking about. We have been living in a world of so-called evidence-based policy for at least 2 decades now. In the US, the term that is more frequently used is explicitly science-based policy. We're a little looser about that here in the UK. But basically on both sides of the Atlantic, authority is accorded to scientific evidence or a particular kind of social science evidence, well, I'll say more about that in a minute, that resembles the natural sciences. And other kinds of social science and evidence from the humanities is frequently ignored, disregarded, or dismissed. Now, some of you may know I spent much of my career in the United States. I came back to the UK 12, 13 years ago to direct the ESRC's Science in Society programme, 2001 to 2007. And in that role, I frequently encountered calls from politicians and from scientists for more scientists in government service. The clear message was that modern governance requires not only understanding of science, technology and medicine in order to be able to evaluate evidence arising from those fields, but also the exercise of a scientific mindset, a particular analytic approach to better manage the social and political technology of government. The message was very clearly, out with the Sir Humphrey Applebys and in with the Sir David Kings. Science, not classics, is best suited, we were told, to inform, even drive policy in the 21st century. But does science drive policy? Should science drive policy? I imagine this audience would probably sound a resounding no, and that we would all be committed to some form or another of the idea of science informing policy or of science co-producing policy rather than driving it. But politicians seem to be much more schizophrenic on this point. Take the celebrated case of Sir David Nutt, Professor David Nutt, rather, sorry, he probably won't ever get a knighthood now, will he? Take the case of Professor David Nutt, who in 2009 was fired from his position as chair of the Advisory Committee on the Misuse of Drugs as a result of his claim that the risks associated with horse riding, one serious adverse event every 350 exposures, were greater than those of taking ecstasy, one serious adverse effect every 10,000 exposures. Justifying his sack of Nutt, Home Secretary Alan Johnson explained in The Guardian that, quote, he was asked to go because he can't be both a government advisor and a campaigner against government policy. And note the next bit particularly. As for his comments about horse riding being more dangerous than ecstasy, which you quote with such reverence, it is, of course, a political rather than a scientific point. Well, no, actually. Responding in the Times, Professor Nutt said, quote, I gave a lecture on the assessment of drug harms and how these relate to the legislation controlling drugs. According to Alan Johnson, some contents of this lecture meant I had crossed the line from science to policy, so he sacked me. I did not know which comments were beyond the line, or indeed where the line was. Now, there are many interesting aspects of the Nutt case, but what stands out to me is that Nutt's argument was clearly backed up by exactly the kind of scientific evidence that the Labour government had committed itself to when it embraced the concept of evidence-based policy. Johnson might have made a very different argument. What he might have done was accept the scientific evidence, and thank Professor Nutt for it, but argued that the government's view of the will of the electorate was that, based on values rather than science, it prefers to ban recreational drug use, but not the more individually hazardous pastime of horse riding. However, rather than assert the legitimacy of values in this decision, Johnson explicitly attacked the evidence as political rather than as scientific. I put it to you that regardless of our views on the legalisation of recreational drugs, as Democrats, with a little d, of course, we might say that Johnson did the right thing in upholding values over science in this case and reflecting the public's popular will, but that he offered the wrong reasons for doing so in attacking Nutt's science. But I think what this illustrates is the peculiar grip of the idea of science-driven policy has in this field. On the other hand, in the area of climate policy, mainstream politicians and scientists who are concerned about public scepticism regarding catastrophic change remain thoroughly committed to the information deficit model. Case in point for some of us, I think, who in this room were probably at the 2012 Planet Under Pressure conference in London, where the science of climate change was repeatedly appealed to as the basis for changing human behaviour and government policies. And in the words of Anne Glover, the Chief Science Advisor to the European Commission, quote, the facts just are. All the while, society was blamed for failing to respond to the urgent messages of scientists and campaigners. Social scientists were particularly and explicitly chided for failing to market the natural sciences evidence and warnings effectively to politicians and to the public. Yet, as social scientists, we are acutely aware that although the disputes about climate change policy are often conducted in the language of science, particularly in the US and to some extent in Australia, lesser so in Europe, but their origins are more deeply rooted in competing values than in competing facts. I have a suspicion that the science wars over climate change actually had their origins in the very early congressional hearings on the topic in the 1980s, when you had people like Jim Hansen going before congressional committees offering both the diagnosis of what the causes of climate change were and at the same time a prescription of what needed to be done. Intervention in markets to constrain greenhouse gas emissions. So in a sense what they did was they offered politicians who were uncomfortable about implementing the prescription little choice, or at least the model of you have to therefore dispute the diagnosis. And therefore I would argue that we've been having a surrogate argument about science for 20 odd years when we could have been having a much more open, explicit argument about policies. And it's interesting that privately many US Republican climate deniers, at least ones I talk to, concede that there's probably something in the science of climate change. But they're not going to publicly embrace concern because, in their view, to do so would be to admit the thin end of the wedge leading to carbon controls. And that's contrary to their values of not intervening in the market. Now, climate skepticism or climate denial is frequently attacked as irrational resistance to scientific consensus. But why should we, or why do we, actually believe anything at all that scientists tell us? How rational is that? Very few of us have the remotest capacity to independently evaluate the knowledge claims of technical experts in fields other than our own. And that, by the way, goes just as well for scientists as it does for lay people when those scientists are venturing outside of their own fields of specialization. And indeed, I think that the strongest scientific agitation for climate mitigation seems to come from scientist activists whose training and specialization is in fields other than climatology. Claims that, quote, the science is settled, or there is no room for doubt about any aspect of future climate projections, are seldom heard, if ever, at the coalface of climatology. If you actually go and talk to the climatologists over a few beers, they'll tell you it's clearly the case that there are real limitations to our present knowledge, even if these are seldom loudly trumpeted in public out of a concern not to give ammunition to climate deniers. The Mackenzie certainty trough seems to be operating in this area. While climate scientists are well aware of the incompleteness of their science, science bigwigs and political activists are the configured users whose confidence in that science is higher than either among its producers or among a wider public. Now, going back again to my time as director of the ESRC's Science and Society programme, during that period we tried to develop the idea of scientific connoisseurship as an antidote to the certainty trough. We were curious that science seemed to be an exception among the fields of human endeavour in that most fields recognise a cadre of individuals capable of making informed, knowledgeable judgments about the quality of the activity being undertaken without necessarily having any capacity to perform that activity themselves. So you think, for example, about the role of critics in art, in literature, cooking, winemaking, sports, architecture, almost anything you want to think of, except, strangely enough, for science, from which a recognised category of non-practitioner expertise is conspicuously absent. Some people will make that claim for science journalists, but I would argue actually that that's not the same role as played by a connoisseur and critic. Now, for the most part, connoisseurship in other fields where it exists seems to develop through learning whose judgments to trust, rather than learning to perform the techniques of the activity itself. Surely, we thought, this presented an opportunity to STS to demonstrate its social value and to secure ongoing support for the field, which, as many of you know, has been difficult to maintain since the end of the Science and Society programme. Needless to say, the idea didn't catch on, save for a brief spark of interest here at Nottingham a year or so ago. So we're still left with the problem of why people invest science with credibility and authority. And I suggest that at least part of the answer is that people trust science because technology works. And there's a popular misconception perpetuated by both scientists and politicians that technology arises from scientific discovery and is dependent upon the theories of science for its effectiveness. Now again, I'm sure everyone in this room would scoff at such an idea. We all know, for example, that powered flight was achieved well before the emergence of the science of aeronautics. And in fact, new sciences are themselves often the product rather than the producer of new technology, from Faraday's electrical apparatus to the electron scanning microscope that facilitated the emergence of nanoscience. But how often do we challenge the linear assumptions of science leading to technology in public policy discourse? And when we do challenge it, what authority do such challenges have relative to the positions of the science establishment with its vested interests in the linear model of innovation that perpetuates large science research budgets? In turning to the issue of authoritativeness, I return to the claim that government needs more scientists, and by implication, fewer classicists or even fewer social scientists. Such a view endorses at least one of two possible ideas: either that scientific training provides a superior basis for decision-making, or, and perhaps that contemporary governance problems involve scientific issues that are too difficult for a non-scientist to grasp. And in so doing, the call for more scientists in government highlights the ascendancy of the epistemic culture of science and engineering over that of the humanities. It also characterises governance challenges as essentially technical and susceptible for adjudication according to evidence, rather than as issues of values requiring skills of interpretation and moral judgment. We don't hear calls for more anthropologists or moral philosophers in government very often. Now, the gulf between science and the humanities is a well-rehearsed one. It's been highly visible since C.P. Snow's Two Cultures paper back in the 1950s. But while Snow didn't explicitly address the social sciences, although in the second edition he did raise what he called, what the field that Americans call government, but he didn't really address the social sciences, I would argue that we social scientists uncomfortably straddle the epistemic gap that he was describing there, and that we are divided by two kinds of social science. On the one side, there is the descriptive paradigm of social science, illustrated here. It focuses on the stocks and flows of tangibles, such as money, oil, population. It also can be intangible, so votes and ideas can also be plotted in this kind of way. It's exemplified in diagrams consisting of boxes, the stocks, the arrows, the flows. It's often equated with quantitative approaches, and indeed it does rely very often heavily on numbers, although in more cases than we often realise, these numbers are not so much real measurements as inferred quantities, theoretically inferred quantities. Now, the descriptive approach arose historically over 2 centuries as part of a larger intellectual effort to enhance the rational management of nature and society by the emerging modern state, including the new field of statistics, which emerged in the mid-18th century as the practice of inventorying the resources of the state. Thus, the descriptive tradition, in both the natural and social sciences, separates us from nature while providing us with a significant degree of control over it. But this control comes with a price tag: separation of knowledge from the knower. Faced with disembodied parcels of descriptive facts, decision makers may become increasingly isolated from the experience of how their decisions affect people's daily lives. The descriptive paradigm flows seamlessly into the natural sciences. For example, you can take an energy emission model, carbon emission model from economics. You can bolt that directly onto a carbon cycle model from the natural sciences, and the outputs of one become the inputs of another, and you can run it seamlessly as a single model. On the other side of the epistemic divide, however, the interpretive paradigm, which I'm about to explore in a little more detail, flows comfortably into the humanities through the analysis of narratives and the exploration of values. The interpretive paradigm in social science focuses on the motivations of people's actions and the frameworks of meaning that they use to understand the world and through which they seek to act upon it. Therefore, it focuses on the nature of experience, the structure of perceptions, the recognition of interests, and the development of frameworks for collective action. The interpretive approach insists that there is no standard standpoint outside of history and outside of society from which they can be observed independently. It therefore tends to emphasise variation in, or even the uniqueness of particular human experience, contingency, and it tends to focus more on the local than the global scale, the local scale of interpersonal discourse. On the other hand, going back to the descriptive approach for a moment. That grew up with the nation state. It tends to assume homogeneity of human response, for example, to price signals, and is therefore capable of high levels of aggregation in its analyses. It takes a global view. The nation state, or the firm, is often treated as if it were one large individual with a unitary intelligence and decision-making capacity. Or, alternatively, the resources of real individuals may be represented by dividing the total resource by the number of people, resulting in a mere per capitan, described here by Mary Douglas and Steve Nye in their 1998 book, Missing Persons. Now, contrasting 16th century iconography with modern satellite imagery, Tim Ingold traces the development of the descriptive approach from the Enlightenment to the present. In Maffei's Scala Naturale of 1564, shown here, the scholar is at the centre of the environment, consisting of 14 concentric circles, forming a giant stairway, the ascent of which, step by step, affords more comprehensive knowledge of the world from the inside out. In satellite imagery, on the other hand, the observer viewing the world from without replaces the scholar experiencing the world from within, thus privileging observation at the expense of experience. And, as Ingold argues, local knowledge originating in experience is downgraded as partial, parochial, and ultimately unreliable. Global knowledge is treated as universal, total, and real. Now, the distinction between these two kinds of social science, the descriptive and interpretive social science, wouldn't necessarily be a problem. Indeed, logically, it might seem that the two epistemic cultures of the sciences and the humanities should be perfectly complementary to each other. But, as is often the case with boundaries, those living closest to the border on either side seem to reserve a special contempt for their counterparts across the border. Descriptive social scientists dismiss interpretive practitioners as fuzzy arm wavers, while the fuzzy arm wavers, and I own to being one of those, return the compliment by describing the descriptive practitioners as mindless bean counters. The descriptive paradigm partly owes its authoritativeness to its apparent concreteness. I say it's apparent concreteness because it's not always clear how justified this is. A.N. Whitehead in 1919 identified the fallacy of misplaced concreteness, the phenomenon whereby the provision of numbers to several significant figures, very often, perhaps embodied in tables, graphs and figures, confer an unjustified appearance of realism upon models and results. And it also derives authority from a double borrowing. It's a borrowing of credibility from the natural sciences, which themselves are borrowing their credibility from the fact that technology works. The two approaches embody quite different normative imperatives for decision makers. The tendency of the descriptive approach towards aggregation leads to a top-down decision-making rationality, while its quantitative approach leads to an essentially utilitarian emphasis. It's a short step from the practice of inventorying the stocks and flows of goods and bads to decision frameworks based on a technique for calculating societal happiness measured by their distribution, as introduced by Jeremy Bentham. In contrast, the tendency of the interpretive tradition to focus on the face-to-face community rather than the nation-state directs the attention of scholars to the particular circumstances of decision-making rather than to the aggregate outcome. Attention to disaggregated particulars articulates with an orientation towards bottom-up rather than top-down decision-making. Goal setting here is more likely to be conducted in terms of rights and responsibilities than aggregate happiness. It's more likely to be phrased in Kantian terms rather than in Benthamite ones. But a focus on the diversity of motives, values and preferences of the individual actually tends to frustrate the utilitarian social accountancy. And this may be part of the reason why there is so much friction between these two modes of apprehension of the world in the social sciences. Because the utilitarian social accountancy depends on blending out such distinctions, as you would focus on in the bottom up, in the process of aggregation. It's hardly surprising, therefore, that the insights of the interpretive paradigm are not merely seen as irrelevant, but actually have to be excluded from utilitarian decision-making. in order to preserve the rationality and legitimacy of the utility principle. So, in summary of this part of the talk, I would say that the distinctions between the two social science paradigms is not merely an artifact for the history of ideas or a scholarly distinction of mere academic interest. It actually lies at the heart of the crisis of governance that pervades the local, national, and global communities. That is, the tension between interdependence and independence, the tension between the greatest happiness of the greatest number, and the assertion of individual ethnic or local rights that ought not to be violated, even at the expense of the aggregate good. Now, these different epistemic and ethical positions are embodied in the descriptive and interpretive approaches, are very much apparent in live disputes today over whether or not research should be conducted into the potential use of stratospheric sulfate aerosols to counteract the effects of climate change. I have to point out that's actually not a stratospheric aerosol distributing plane. It's actually a silver iodide distributing plane, but it's the closest image I could get to representing this technology, which at the moment is still very much at the level of technological imaginary. So the absence of a proper picture is actually illustrative of the early stage at which this debate is. However, stratospheric aerosols have the potential, or it's been argued that they have the potential to be relatively cheap, fast-acting, and are said to be close to being deployable. Therefore, it's argued that they merit serious consideration alongside conventional mitigation adaptation as a tool to help deal with climate change. Opponents fear that the same characteristics render stratospheric aerosols potentially catastrophic, inevitably inequitable, and ultimately ungovernable, so that even conducting research on them is at best a waste of resources, or at worst the first step on a slippery slope towards an unacceptable outcome. Indeed, critics argue that even conducting research to explore the potential of solar geoengineering ought to be considered beyond the pale. Now, both supporters and opponents of research agree that there are huge uncertainties, and presently much that is simply unknown about the potential deployment of stratospheric aerosols. Under these conditions, the call for more research to understand the technologies, their intended and unintended consequences, and the conditions under which they might be deployed, if at all, may seem modest and rational. Yet even the idea of conducting research on the potential of stratospheric aerosols has been highly controversial, and various arguments are deployed on either side of the issue. For example, opponents of the research worry about what insurers call moral hazard. They fear that even doing research might send a signal to people and policymakers that they can let up on efforts to reduce their greenhouse gas emissions in the erroneous belief that solar engineering will save the day. Some advocates of research have expressed some opponents of research have expressed concern that future claims of a climatic emergency, where there may be a strong likelihood of reaching a disastrous tipping point of some sort or a runaway climate change, might lead to the implementation of solar geoengineering without adequate understanding of its behaviour. This is an argument that critics have described as arming the future. But both sides agree that humanity currently lacks the knowledge that would be necessary to deploy stratospheric aerosols on any scale. They're dramatically divided by their response to such ignorance. And the arguments are well represented in two little books aimed at general audiences, both of which I commend to you, because they eloquently summarise the cases for and against respectively. The case for research is made by a North American engineer, David Keith, and that against is authored by a British geographer, Mike Hulme, and both have extensive backgrounds and are widely respected in climate change policy issues. Now, the research advocates argue for improved computer modelling, accompanied by complementary small-scale experiments, gradually and cautiously scaled up over time. They see this as a pathway to deliver robust knowledge to inform decisions regarding full-scale implementation while avoiding any irreversible negative consequences. However, opponents of such research argue that while computer models are reasonably good at predicting global temperature in relation to greenhouse gas concentrations, they remain poor in relation to other climatic factors, such as precipitation. They argue that the complexity and uncertainties inherent in the climate ecosystem's responses are so massive that even if they were better understood, they could not properly be represented in any conceivable computer modelling of stratospheric aerosol deployment in the foreseeable future. Under these conditions, writes Mike Hume, that to embark on this course of action would indeed be to conduct a giant experiment, a leap in the dark. He goes on to say, I do not believe the human mind has the ability to fathom the intricacies of how the planet functions. The models on which aerosol injection technology would rely are like calculative cartoons. There are limits to human knowledge. Our species is a product of evolution, not its author or controller. Now, against this view of irreducible ignorance, it can be argued that the perfect should not be the enemy of the good. The only way we can learn more about what ignorance is reducible and what ignorance is irreducible is to conduct research. And in marked contrast to Hume, David Keith writes the following: our knowledge of the risks isn't purely theoretical. We can actually draw on the example of Mount Pinatubo to derive a lot of information about these things. Every year we in any way put 50 million tonnes of sulphur into the atmosphere as air pollution. He says, this is not an argument that we should ignore the risks of putting 1 million tonnes of sulphur into the atmosphere for geoengineering, but it should give confidence that there's a strong empirical basis on which to assess these risks, and it is a reason to suppose that risks will be comparatively small. So for those of Keith's mind, not to do research is to remain ignorant of our ignorance. While research may not fully answer all of the questions that we would like, a well-designed programme of cautious research with clear stage gates and reviews, according to this view, has the potential to provide a better picture of the form and behaviour of solar geoengineering technology. And perhaps such research would actually help to definitively clarify the case against deployment, taking the issue off the table once and for all. So why do the protagonists take such different views of the same evidence, or rather lack of evidence, the same lack of evidence, about the promises and pitfalls of solar geoengineering research? And to cast some light on this question, I turn to the related ideas of epistemic and institutional cultures. The concept of epistemic cultures specifically explores the operation of comparable epistemic preferences in the sciences with regard to how they generate both knowledge in the works of, for example, Corinne North-Cetina, and also how they generate ignorance or non-knowledge in the work of Boschen et al. And then particularly the latter identify three kinds of scientific epistemic culture. The first is a control-orientated scientific culture of non-knowledge, characterized by an epistemic focus on the control of the experimental conditions and the avoidance of disruptive factors. The second epistemic culture they identify as, quote, a single case-based experience which shows a tendency to define non-knowledge as a problem of the individual expert. And the third is a complexity-orientated culture characterized by a high degree of openness towards unanticipated events as well as uncontrollable and context-sensitive settings. Now, these three epistemic cultures are drawn from STS, but they're strongly redolent of the theory of institutional culture originated by Mary Douglas in the 1970s, which proposes that hierarchical, competitive, and egalitarian ways of organising each sustains and is sustained by characteristic argumentative frameworks, characteristic appeals to sources of authoritative knowledge, and procedures for dealing with uncertainty and ignorance. In brief, the hierarchical cultures tend to favour carefully designed stage procedures with well-defined decision rules. As such, they often attract the sobriquet technocratic. Competitive cultures place a strong emphasis on individual judgments, craft skills, and the right stuff. Egalitarian cultures generally place a strong emphasis on extensive discussion and debate involving a wide cross-section of actors, often seeking to amplify the voices of the weak and the powerless. Hierarchical cultures, therefore, are likely to view ignorance as susceptible to domestication through the cautious application of well-designed technical processes as described by Keith. He says basically here, if we had a one-time choice between going all out for geoengineering and not doing anything, I would choose not doing anything, but this is not the choice. He says our choice is between the status quo, with almost no organised research, and commitment to a serious research programme that will develop the capability to geoengineer, improve understanding of the technology's risks and benefits, and open up the research community to delete the geoclique. The geoclique is reference to the small group of people who are making geoengineering proposals these days. Given this choice, I choose research. And if the research supports geoengineering's early promises, I would then choose gradual deployment. On the other hand, the egalitarian cultures will seek to frame the same issue as requiring extended discourse and resistant to settlement by appeal to technical resolution. For example, Mike Hulme writes that aerosol injection is not simply about stabilising or restoring the global climate. It is an intervention that has profound repercussions for what we think it is to be human. It would forever alter our sense of moral duty and ethical responsibility. I make my position clear. I do not wish to live in this brave, new, climate-controlled world. Now, the different approaches taken by Keith and Hulme seem to indicate clearly linked epistemological and ethical preferences. Keith's arguments reflect the hierarchical and control-orientated cultures that might seem to characterise the engineering disciplines and what we've described above as the more quantitative descriptive style of social and policy science. Hulme's arguments, on the other hand, display the characteristics of the egalitarian and complexity-orientated cultures that we might expect from what we have described above as the more qualitative and interpretive social sciences. Keith is taking an essentially utilitarian approach to decision-making, focused on maximising the general welfare, while Hume's approach points to a more deontological, rights-based, duty-based, or virtue-based position. In summary, the rhetorical deployment of ignorance in the case for solar geoengineering seems quite straightforward. And that's conducting some research is the only way to reduce ignorance about the technology. However, the case against solar geoengineering research seems to be twofold. Firstly, ignorance is a binding constraint. We simply cannot know. But even more interesting, ignorance is a source of virtue. It preserves us from folly. It's hard, if not impossible, to see how these different perspectives could ever be reconciled by appeals to evidence. Indeed, it may be that the geoengineering debate is at a point that's almost never recognised in other technoscience debates until the moment has passed. At the present time, the value differences are clear and explicit, and the debate is being conducted on the basis of values that are very close to the surface in the argument. There are no strong science claims to hide behind in articulating those values. Quite the contrary. Everyone seems to acknowledge that we currently know very little. Once research gets underway, if it does, then the debates will likely change and explicitly begin to focus on what's being learned by the research and what it tells us. And once that happens, debates over the science will displace the debate over the values. While in principle this doesn't have to happen, we know from climate change, from nanotechnology, from GM foods, etc., that it always does. So now we have a moment of clarity. Capturing that clarity and making sure it does not get corroded, camouflaged, or otherwise elided in the form of competing knowledge claims seems to be a worthy governance or policy goal. Thank you.
Thank you very much, Steve. I think we've got about 10 minutes for discussion until the next panel starts. Who would like to ask? I'm sure there are. Yes. Is there a microphone?
I can shout.
Here it is.
Okay. So,
yeah, there we go. So Philip Moriarty, I'm a physicist here at Nottingham. So it was interesting that I don't think any of us would argue for the total validity of the linear model of innovation. But it was interesting that you inverted that, and you seemed to say that, well, actually, technology never stems from basic research, because, in fact, it's a feedback loop. That was certainly the message I got. Your point about nanoscience is interesting. I'm a nanoscientist, because, and really it's a good example of where basic research certainly drove technological development, because the development of the scanning probe microscope, which is different from the scanning electron microscope, actually arose from a very fundamental research project to investigate quantum tunneling. So that's a really good example of where the origin of nanoscience and nanotechnology actually stemmed from basic research.
Sorry, I didn't mean to imply that there was I did not mean to imply that I see a simple reversal of the directionality there. Obviously there is recursive feedback, but each time you make a fundamental new scientific discovery, you're using apparatus. Apparatus is technology, it's not science. Now it may work, so basically if you go back historically all the way, but what I think though in the policy field, if you look at the continuous justifications offered, for example, for the US national science budget, it's the idea that we must have this big budget for blue skies research, that scientists must be able to go out and pursue whatever interests they have, because they will come up with the ideas which will eventually find their way through to becoming technology.
I agree, that's entirely what
and it's that model of we believe in science because we like the outcomes in technology that I was trying to highlight.
And it prefers science.
Any other thoughts?
It's a slight shift in perspective, but I
sorry for the microphone.
The sound system is so awful in this room. Somebody should do something about it. He was much clearer without the microphone than with it. So if you forgive me, I'll move. Okay?
Yep.
Well, the thing is, it's recorded on podcast. It will not be on.
Oh, right. Well, it's worth recording. I run a group that does engineering research and education, and as we take a systematic view combining design and development, and people appreciate the results. When I look at the policy level in education, I see that no thought goes into design and development of a systematic kind. And indeed, when policies are formulated, most of them have doom written all over them from the beginning. Because although there's plenty of ignorance about how the whole system works with its multiple constituencies of sometimes conflicting interests, there are certain things we know, and these are widely ignored. If I might give you one example. I quoted the Akron Witty Week 30 years ago. What you test is what you get in high-stakes examination systems. It's now actually pretty widely accepted, but not acted on at a political level. So the exams are done under a whole set of pressures, quite separate from the learning goals and so on. So the question is, ask for your comments on actually using scientific, or rather I would prefer to say engineering methods, in the development of policy. There's a commitment to piloting, but the design of what is piloted is usually done by wise people around the table. Any comments?
Well, I think you're opening up a huge set of questions there. But I think one of the problems in many areas, such as education, health, and so forth, is that there is actually insufficient conversation going on between, on the one hand, the people who crunch numbers and look at it from a statistical standpoint, and from people who actually then go and look at things like healthcare and education from the interpretive social science point of view. And inevitably, what tends to happen is we have surrogate arguments about numbers rather than about what are the values that we're trying to actually realise in our health and care and education policies.
Yeah, because nearly all our design is based on the same kind of qualitative feedback you're talking about. My favourite sample size is 5. Of course, you look at the outcomes in terms of numbers, but if you need statistics, you're in deep trouble because the variability of implementation is such that small effects are wiped out.
Well, I'm not sure I would agree with you that my favourite sample size is 5. Therefore, I'm going to dismiss the interpretive kind of social science.
I think it is interpretive.
Yeah, but I think that's in a sense the caricature of interpretive research. But I think more to the point is, in any case, it's a point made by Dan Sarowitz, which is in all of these fields, basically, we generate vast amounts of evidence from which people can come and cherry pick the particular evidence that supports their particular value system. So, and this is my point at the end, which is you can't resolve value conflicts by resource to facts. And we saw this. One of the clearest examples of this was the National Situation Assessment Programme in the US, where millions of dollars were spent on producing a very wide range of science, looking at the problems of sulfur dioxide emissions and acid rain, and eventually produced what I think it was Chuck Herrick described as a smorgasbord of science from which members of Congress then came and cherry-picked the particular paths they wanted to support the positions they've been taking all along. And I think that's typical of these kinds of
No other questions? Can I ask? Yes, okay.
Oh, just yell.
Paul Matthews from Nottingham. You started off with your first example from David Nutt of the drugs policy issue, which you said was not a political statement. You then moved on to climate change, and I was interested that then you talked exclusively about the US, and I was wondering why that was. I asked this question on Twitter, and I've already got an answer actually, but I'll ask it anyway. So.
What was the answer?
You spent a lot of time in the US, which is just wanted to point out that that there are climate skeptics in the UK. There's one of the most prominent UK academic climate skeptics is at your own university. So a chap called Jonathan Jones in the physics department. So he was the chap who fought.
Don't meet in your own
well, yes. I mean, he was the chap who forced the University of East Anglia to release their data with the sequence of freedom of information requests. So, yeah, I'm wondering if that might suggest there might be a hint of anti-Americanism here with, we all love to blame the US for all the world's problems, and if that might be a factor.
Oh, well, yeah, I mean, if you want to get me off on my climate shit, I think exactly one of the reasons why the Europeans were trying to take such a lead in the climate negotiations, a position of leadership from which they fell rather embarrassingly flat on their face at Copenhagen, was precisely to differentiate themselves from those nasty Americans who aren't doing anything about this, with virtuous Europeans. It's interesting that the climate change issue came up at a point where, in fact, I would argue at least, and Roger's a political scientist who probably knows better than me, it was a place where basically political power in the US was centripetal. It was moving out from Washington back into the States after having been probably at the highest point of federal concentration in around 1969-70, when you had things like the National Environmental Policy Act, the Clean Air Act, the Clean Water Act, all by the way signed by Richard Nixon, a Republican. And you had just had the Civil Rights Movement. And since then, I think the political power has been dispersed back into the States. At the same time, in the UK and Europe, you had Maastricht coming together and the idea of the European project trying to bring things together. Now, climate change represents a very different opportunity for politicians under those two situations. And in the first, it's more likely to lead to disputes about circumstances under which the federal government might want to intervene in the markets, intervene in the prerogatives of the states. In the second case, it's a wonderful opportunity for us all to pull together in the face of a common danger and also point to those nasty Americans who aren't doing the right thing. So yes, there's a lot of that in the conflict.
Was there one more? Stuart.
Stuart Parkinson, Scientist for Global Responsibility. I guess I can ask a simple question that probably has a very long answer, but I'm going to try anyway. Where do you suggest that climate scientists go in the debate? Should they pull out of a debate and say this is a values argument and you need to debate the values much more openly, or where would...
I would sort of take a leaf out of Roger Pilkey's book here. I think scientists are scientists, and scientists are also citizens. And as citizens, they have every right to engage in public policy discourse. But I think that I would like to see a lot more clarity that when they do so, they're doing so as citizens and not as experts. Because I think very often that expertise is not necessarily appropriate to by implication, I was beginning with the uncertainty trough, that a lot of the scientists who speak mostly about climate change are not climatologists. Professor Steve Rayner, for example, is a surface sciences. That's the case with the current US presidential science advisor, John Holdren, is not a climatologist. So basically, I think in many cases, they're borrowing their scientific roads to intervene in ways with authority that is not.
What about Stern's position? Essentially a business risk argument. The Stern report.
Are you asking me for my view of the Stern report?
Your response to his attacks,
Do you want to take? We are pressed for time. We've got two more.
That would have to be a very long answer.
Yeah, I think we got two. If that could be brief. So yeah, okay.
I just wondered if you'd seen much influence of politicians who come from a scientific background, like Angela Merkel, for example, was a physicist for a number of years. Does that have any impact on the way that they approach policy?
Well, again, of course, the most famous example is Margaret Thatcher was a chemist.
Exactly.
And she knew what real science was, and that's why the Social Science Research Council had to change its name to the Economic and Social Research Council. Because whatever it was those people do, it certainly wasn't science. She had an undergraduate chemistry degree. I think that probably is an indicative.
That's an example of one.
I don't know. It's very variable. Again, I think people will. I'm rather cautious about this idea of having a scientific background, which doesn't actually, which is sort of non-specific, as if somehow or other science is fungible. One of the things I found bizarre when I was working at the Oak Ridge National Lab as a relatively junior researcher back in the 1980s was we would do, it was great fun because we were really interdisciplinary stuff with engineers and biologists and ecologists and all the rest of it. And then they'd say, we need a social scientist. And their project would have, a terrestrial ecologist, a wetland ecologist, a hydrologist, a geologist, and all the rest of it. And then the rest is good. We'll get one of those social scientists to do the social science. It's a bit like us saying, well, we need a scientist. And we did that sort of tongue-in-cheek, but people laughed at us for the obvious reason.
Isn't the Oxford Martin School a little bit like that, in that it tends not to have critical mass in that particular place?
The Oxford Martin School has no critical mass at all. The Oxford Martin School is an attempt to create a mycelium of connectivity across the university. It was not actually it's not a department.
Okay, Philip.
Very quickly, because I'll pick up on quite a few of these points in the last panel session, but Dave King is a surface scientist, agreed, but the basis of surface science is chemical physics and physical chemistry. Now that, of course, is relevant to climate change. You cannot dismiss that he has an understanding of chemistry that is going to be exceptionally important in terms of bringing a different and important expert opinion to bear on matters of climate change.
Again, I didn't say that. I didn't say it was irrelevant.
Well, you said he should come out as a citizen rather than a scientist.
Well, because I think certainly it's incumbent upon scientists engaging in policy debate to be clear about the scope and of their particular expertise.
Absolutely, that's very good.
And when Dave King was coming out and saying words to the effect of the models have been parameterized, tested, and so on and so forth, they are entirely reliable. Was that based on his achievements as a chemist?
No, but that's a separate issue. That's a separate issue. You're saying that he should not bring to bear his related expertise in the field.
No, I didn't say that. I absolutely did not say he should not bring it to bear. What I was saying is that you don't borrow the credibility you have from your expertise in one particular field to make pronouncements beyond that field as scientific pronouncements.